Hello and welcome back to Josh Does Math. In this video, we've got a problem that you probably encounter near the beginning of calculus whenever you're just learning what a derivative is and how to use them to create tangent lines. So for this problem, we're going to find the equation of the tangent line to the curve y equals 2x squared plus 1 that is parallel to the line defined by this equation here. So we're finding the tangent line to this parabolic curve, and that tangent line is going to be parallel to this line they give us right here. Well, how about we write this using y equals mx plus b, because that's what we're trained to do, so you can visualize that a little easier than what they give you. So I just subtracted 8x and added 2 to each side, and I got that. So let's say I were to graph this. So it's got a pretty steep negative slope, and we just shift it up by 2. So it's probably going to look something like that. Imagine that that's a straight line. It's going to look something like that. And this other curve that they give us, y equals 2x squared plus 1, that's going to be a parabola that's stretched upward and shifted upward. So that's going to probably look like this, like that. So I'm going to extend this line that I originally drew. Now everything disappeared. I'm going to extend this line a little bit. Okay. So I'm looking for the equation of the tangent line to the parabola that's parallel to the straight line that I just drew on there. And you can see that point's going to be probably right here. Not that point, but rather that tangent line is going to be right there. Right on the edge, the lower left edge of the parabola. So I'm looking for the equation of that line. Okay? Well, in order to find the equation of that line, assuming I want to write that as y equals mx plus b, I'm going to need the slope of that line and the y-intercept of that line. So I should look at the slope first, see if I can figure out what the slope of that line is. Well, they tell me it's parallel to this. If it's parallel to that, it's got to have the same slope as that, so that the two lines never cross unless they're parallel. And the slope of this line is -8. So that means the slope of the line that's parallel to it also needs to be -8. Okay. And now I know that this line needs to touch the parabola at some point. It's got to touch it, we'll say, right here. We'll say that that's at x1 is where it touches it. It's at x1, comma, y1. So that's the point where it touches the parabola. Okay. So if I go over here to use my y equals mx plus b equation, I know y1 equals m is -8, x1 plus b. My goal is to figure out what b is. Okay. Well, I know that y1 is going to be just this equation up here. It's going to be this equation up here, except for I plug in x1 for x. Since this equation up here gives me the y value on the parabola for every x, if I pick out x1 and it's on the parabola, then its corresponding y value is defined by this equation. So I just use that equation and stick x1 in there. So I have this equation, and this would be great if I knew what x1 is, if I knew where this tangent line is parallel to the other straight line. If I knew where that touched the parabola, that would be really helpful, because then I could figure out b. And once I figure out b, just plug b in, plug m in, and I'm done. So my goal is to get b at this point. Okay? Well, I know that at this point on the parabola, the slope is -8. And we haven't done anything with derivatives yet, and here's where the derivatives come in. If I take the derivative of this parabola and set it equal to -8, I can probably find the x value where that derivative is -8. So that's what I'm going to do. And you can figure out the derivative two different ways. So here's the easier way if you know how to do this. This is the power rule for derivatives. It says power out front, one smaller on the power. So I want to find dy dx. It's dy dx. And that's going to be y up here. For each term, I go through each term that is just a power of x, and I pull the power out front, and I make it one smaller. So power moves out front, so you get 2 times 2, one smaller on the power, that's x to the first power. Do the same for the second term. What's the power here? Well, this is actually, if I write 1, that's the same as 1 times x to the 0. So the power comes out front, it becomes 0 times 1 times x to the 0, which is also just 1. But all this doesn't really matter. You're multiplying by 0 now, that's the thing. And since you're multiplying by 0, that whole thing is gone. So here's what we have. And I can rewrite this as 4x. So that means that the rate of change of this parabola at some given x is 4x. So that's one way to do this. If you didn't know how to do this, you could use the definition of the derivative, which is the limit as h approaches 0 on f of x plus h minus f of x all over h. And you take that limit. And if you do that limit, you'd have to FOIL and distribute some stuff, but you're still going to get that. So this is the rate of change of the parabola as a function of x. That's all that the derivative is. And I know that at this specific point, right over here, x1 comma y1, the rate of change is equal to -8. That's what this tells. This is what this means up here. So I'm just going to solve for x. I got to figure out what x value results in me having a derivative of -8. Okay? Dividing by 4 on each side means x equals -2. So at -2 comma whatever the y value is, I get a slope of -8. Which means over here, that's what the x value is going to be in this equation here. x1 is -2. So I'll plug in -2 over here. Here's what I get. -2 squared times 2 plus 1 is equal to -8 times -2 plus b. And if I solve this, that's 4 times 2, 8 plus 1. That's 9 is equal to 16b. 16 plus b. Subtract 16 from each side. I end up getting -7 is equal to b. Okay, so I know what b is. I know what m is. So I think I'm done. Just bring this equation down here. Plug in m, plug in b. Y equals -8x minus 7. So that is this equation, this curve that I graphed, rather the straight line that I graphed over here. And just looking at it, comparing it to this, y equals -8x plus 2, you can see that they have the same slope, which is good. That's because they're parallel to each other. You can see it shifted down a little bit. Just from our drawing here, yeah, it is shifted down a little bit. -7 seems like it's a really long ways down from the drawing that I made here, but this drawing isn't to scale at all. So the fact that it is shifted down, though, is a good sign that this is the right answer.